Ladies and gentlemen, welcome to Dorkbot number 3. We are really glad that we can present Dorkbot number 3 here in the Metalab. The Metalab, for you who are the first time here or watching this at home or wherever, the Metalab is the first real hacker and nerd space in Vienna. And that's actually a good place to present today's Dorkbot, because today's Dorkbot is called Hacking Game Machines. So you have never heard about Dorkbot, so what is Dorkbot? Dorkbot is a worldwide movement of presentations founded by Douglas Repetto from New York City, and his basic idea was to bring together people working in the art community, in the media art community, in the net art community, and people who are doing hardware hacks. So basically, it's a presentation of artistic and creative hardware hacks and things that somehow could be called deconstructing machines and reconstructing machines. So that's Dorkbot. This is Dorkbot number 3, Hacking Game Machines, with Martin Pichlmair. And I think that's more intro than I can bear. Okay, so welcome Martin Pichlmair. It's your stage now.
Thank you, Johannes. First of all, it's not only my talk, but there's also Faris Kayali and Petro Kotik, who will also present stuff today. So, okay. Start this. Okay. Hacking game machines. Today I will present the pinball edition of Hacking Game Machines. What you see here is called Bagatelle Concrete, which is, well, I will explain the name, where the name comes from later. It is de facto a kind of hacked pinball machine. So this is the main piece I will present today. But before that, I will kind of show what I've done in the last years with electronics, with technology. One of the art pieces I've done, somehow my remote, now it works. Now it went too far. Okay, one of the art pieces I've done recently is this 7 Mile boots with Laura Belloff and Erich Berger. They've been on show various times now in places like on the Jazz Electronica Festival. Recently they've been to Gijón in Spain. Then we had them in Estonia, in Tallinn, and in Maribor, and so on and so on. So they were shown quite widely. It's a kind of networked boots, so it's also it's hacked boots basically. Boots that you can use to walk through the internet over chat servers. So you put them on and you can walk from one chat room to the next chat room. And if someone is talking in the chat room, I don't need to explain what a chat room is in this audience, to this audience, of course. Then you hear people speaking through these tiny speakers down here. So you can listen to them. It's synthesized voice, so people talk using text messages, but there is a small text-to-speech system on the boots that translates it to spoken words, and you can listen to them, and if you don't like what they talk about, then you can just travel on to the next chat room and listen to those people. It's an eavesdropping boots device. Okay, another piece, just to give you a kind of context of what I'm working at. That I'm working on now is Tratti. Tratti is a kind of musical instrument for children. You can see Ada and Ada, Swedish Ada versus Finnish Ada, with varying Trattis. The Finnish device will be more colorful than these prototypes, but it's a kind of megaphone, a bullhorn that you can put on your belly, and it amplifies and manipulates what you're talking into it. In here is a mobile telephone, because it's a small device that can handle multimedia data. The telephone just does strange stuff with your voice, basically. There's the telephone microphone that records the voice, and here is the speaker is connected to this bullhorn, so it's very loud. And here is the camera that records an image, and this is used as the data for manipulating the voice. So where you face the device somehow changes how the voice is manipulated. Yeah. So this is, it's also kind of a game like a pinball machine, but not in this strict sense. It's more, it's a toy, it's a musical toy for kids. But today we talk about the pinball machines and we talk about hacking game machines. Before the internet or before networks, the term hacking or a hack was obviously coined on the MIT campus as another term for a prank. So they did, you know, these American students, they somehow obviously are very creative in doing very strange stuff on the campus. Maybe it also comes from this campus atmosphere, I don't know. Anyway, they put cars on top of large buildings and fake cars, or they just dress up a dome as a, I don't know, as a Christmas tree or anything. They constantly pull these pranks. And on the MIT, pulling a really good prank was called a hack. Later, hack was used just as a term for maybe exactly what Dorkbot is about, doing strange things with electricity. Just misusing something, opening it up, re-engineering it, putting it together as something new, something like that. Even later, the term was then used for this black hat cracking stuff, like breaking into networks. So there is a longer history to the term hacking, and what I am talking about today is this older meaning of hacking, not the prank meaning, not the cracker meaning, but the in-between, where it was just playing with electricity or electronics. Doing strange things with existing electronic devices like pinball machines. There are a number of examples out there of art pieces similar to these art pieces that somehow are based on a game that was re-engineered and changed. And one of the best known examples is this. This is Super Mario Clouds from Cory Archangel, an American artist who took the cartridge of the old original Nintendo game, Super Mario, and removed everything but the clouds. So it's just, when you put the cartridge into an original Nintendo console, the Nintendo Entertainment System, then all you see is these clouds floating by. Now, if someone like me who knows Super Mario sees this piece, he's of course instantly reminded of Super Mario. It's like the essence of Super Mario, seeing these clouds slowly drift by. And it's a hack of the original console cartridge. He even distributes the instructions on how to build your own modified Nintendo cartridge, including all the soldering information. So what he did was somehow place his own microcontroller inside the cartridge or stuff like this. I don't really understand it. He did a lot of assembler programming, thing that is stuff that is too technologically advanced for me. Actually, I mean, I know a bit assembler, but I'm not really an assembler programmer. Yeah, so this is an example of a very elaborate game machine hack, obviously. Another piece that is the only similar piece to ours out there yet that I know is the Terminator. That is also a kind of hacked game machine. What you see here is also a pinball machine. The pinball machine itself is up here. It's a Terminator 2000 pinball featuring Arnold Schwarzenegger's voice, by the way. And usually you don't need a chair because this can move up and down, but this is a kit that is playing now. What you have here is, you can see it, but I know it, is two old QuickShot 2 joysticks. They're used as triggers like these. And you put your head inside and have the playing field of the pinball machine in front of you, like directly starting about here, and there is no glass on top of it. So it's a first-person pinball machine. I played this piece, and it's quite immersive. So you also have a force feedback helmet in there that shakes your head when the ball hits something. I think it's triggered by the sound. It's very intense, very intense. But it only inside there's basically the starting point is only this old pinball game that was not changed at all. You have everything of the original machine in there. If you're game over, then it says I'll be back, if I remember it right, meaning you be back. This piece was built by Fur, who also did the Paint Station. Of course, most people know the Paint Station. Modified Pong game, which I don't mention here just because it's not really a game machine hack. They custom built a new Pong machine. They just used the old Pong game as a starting point, basically. So what they did is, you all know Pong. 2 pedals, ball, ping, 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 this one. What happens if you miss a ball? Usually the other player gets a point. In this game, you just get somehow tortured by this machine if you miss the ball. So either you get, what you see here is the heat down here, then you could also get an electrical shock because this is leading metal, and you have to place your hand there, so it gives an electrical shock. And these marks are from a whip that is somehow, don't need to explain this in detail. It really hurts. It really hurts. You think it's harmless the first 2 minutes, but after 5 minutes, it really hurts. And people still play it like addicts. You can't remove your hand, because if you take it away for more than I think 3 or 4 seconds, then you are game over. So and the high score table is of course altered too. So the best player is not the one who scored the most points, but the one who endured the most pain. Hence Paint Station. They also had a kind of legal conflict because of this Paint Station logo that somehow distant reminds of the PlayStation logo. They are not allowed to use it anymore. Yeah. So these are some examples of game machine hacks out there. Especially the Paint Station is quite widely known. Yeah. Now to Bagatelle. Fares and I have been working on this piece for, I don't know, how long did we work on it? Half a year now? Yes, more or less half a year, yeah. Maybe even longer. We got a small grant from from Franz Morak back then, and had enough money to buy this used pinball machine on eBay. And our plan was from the beginning to turn a flipper machine, a pinball machine, into a music device. So this is a musical instrument. It's not a pinball game, or it's still a pinball game, but first of all, our goal was to turn it into something that produces music instead of a high score. So our first step was, of course, to remove this scoreboard up here. We don't miss it anymore. We don't even know how it looks if you have it up here. But there used to be a scoreboard up here. I have photos back then, but I need to skip over this maybe. Anyway, half a year ago we started to work on it. So in the beginning, we somehow said that this art piece will be so, we will have so many decisions that we somehow needed to narrow down our road ahead to somehow to keep the focus. We had to restrict ourselves, because you can build anything out of a machine like this, of course. So we had a lot of quite complicated plans, but soon we realized that we need to make something very straightforward, because otherwise it will be too ambiguous, and it will not fit to the straightforwardness of the original pinball machine, which is just ball, stuff on the playfield, play, get a high score. So first of all, we decided that if we do something with music and we hook up microphones, we only use sound that is produced by the machine itself. This led to the second part of the name, Bagatelle Concrete, because concrete is a reference to Musik Concrete, musical tradition started by Pierre Schaeffer in around the, I don't know when he started it actually, must be the 40s or something, 50s maybe, I'm no music expert. What he did was he used tape decks to record sound and built music pieces that were based on sound recordings, sound loops, glued together of course, but also playing live together with a tape recorder. music like this, something that is completely normal today in hip-hop music, for example, to use samples, was first started by those people back then. Yeah, so somehow we after a bit of thinking, we decided that we stick to this tradition of just sampling, manipulating the loop only slightly, cosmetically, and playing it back faster, slower, small parts of it. But we wanted to just focus on these single loops and give the player the ability to play it together with his own loops. So you will maybe if you know this, you listen differently to the machine. The other part of the name Bagatelle Concrete comes from Bagatelle, which is the name of a castle in France, where one of the most popular ancestors of the pinball machine was first presented to an audience, to this audience. That's Louis XVI and Marie Antoinette, his wife, and some of their kids, or maybe all of their kids, I don't know. They were kind of interrupted during their life by some tragic happening called the French Revolution. And a guy, do I have his name here? No. I don't have his name, but someone presented a game called Bagatelle to this audience, which was based on a playing field, a cue, like in billiard, and a ball, and you were playing you were playing this ancestor of pinball without pads, of course, but just on a narrow surface, playing with a cue, and the ball went up and it went down to a specific point, and then you scored depending on where it landed. I will have a photo later. Anyway, I still have this is the only shot, the biggest shot you get of the Castle Bagatelle. I suppose the building itself is bigger. Yeah, the end of the Kings. I also built a. You can do this with slides now. This was the end of these people that. The original Bagatelle was presented to. Yeah, Bagatelle. So this is about what it looked like. This is a later machine actually. It has a different name. It's, no, I don't have the name here. It's a special kind of later Bagatelle machine. But you can see the principle. Here the ball is shot up using a cue. So it's basically the same as any pinball machine has it. And then it goes up here, bounces against some stuff here, and it goes down. This is nails. So it goes like tick, 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 and it falls into one of these pockets down here. The pockets are numbered, and in the middle you score more points. Some of you might know this principle from school. At least my math teacher went into school and brought us a so-called Galton board, named after Francis Galton, one of those people who started the probability theory. It's a board, it looks exactly like this, so it's used for teaching nowadays. Pinball machines somehow obviously are somehow late-born teaching materials or something like this. Anyway, it of course gives a normal distribution down here, so it's a very, very nerdy game. Well, most games are based on probability, so these things anyway always have to do with each other. So this is, but just context. This is how the pinball machine was started. A bit later, the first electrical pinball machines were presented. This is Baffle Ball. It is one of the. It was distributed in America for 1 cent. You could play pinball. You got one ball for 1 cent. I threw it in. And it had, I think, 4 bumpers up here, and then it went down in one of these pockets again. So it's basically still the same machine, it just takes a coin. That's the difference, the main difference. This was distributed for $17.5 to bars in all over America and England, and it was a huge hit. Back then. It was invented by David Gottlieb, who more or less started the pinball business anyway. Gottlieb pinballs are widely known. In the year 1947, Humpty Dumpty was introduced, the first flipper that has the shape and the functionality of modern pinball machines, because it was the first to have so-called, actually these are called bumpers. these workout bumpers back then, because they bumped the ball. It was the first the pinball machine that has these flipper pads, bats, that you can throw back the ball. It also reads, you can read it of course, but it's phenomenal and blah blah blah. And there's, with skill and timing, players can control balls and send them to something right back to the top of the playing field. So this was completely new, that you not only got one ball, it fell down, game over, but you got more than one chance to get the ball score up there. So the first modern pinball machine, Humpty Dumpty, 1947. Then came in the 70s, the next, or yeah, around in the 70s, the next revolution came with these electromechanical pinball machines. Then in the 80s, the first microcontroller-based digital pinball machines were introduced. Then in the year 2000, the pinball machine died a quite horrible death when Pinball 2000 was somehow, it was the pinball machine that tried to be a video game. It had a screen, I think it was up there, and this is just a reflection of the screen, and it played some video clips and special effects at the same time you were playing. It was somehow an over-the-top, hyper-expensive pinball experiment, and it was so expensive that it ruined the last pinball machine manufacturer, Williams. Star Wars was one of the last pinball machines produced. Nowadays, there are sometimes small companies, joint ventures. It's a kind of grassroots movement, but basically the pinball business is dead. But that is only in the machines. Of course, there is also software. There is pinball from Nintendo. I don't have a year here, but since it's a Nintendo Entertainment Systems, it must be late 80s or something. Looks like this. Actually, I tried to get the Windows pinball machine screenshot, but I didn't remember the name of the one that came with, I think Windows 2000 had a pinball machine. So I found two on Ubuntu, which is anyway better. So it's quite usual to have pinball simulators. They are still produced, and there are even some very, very strange pinball games out there, like Odama from Nintendo 2006. Which is a battle game, strategy game where you set up armies, and then you have this kind of medieval huge pinball machine, and you roll a ball through the army. I have another screenshot because it's so. I need to get this one because I think it's really funny. There's also a cannon down here and stuff. I don't know. It's a very weird, very Japanese idea. Okay. So the software pinball games, software games are obviously still very alive, while the hardware is dead. So what about reviving hardware? When we bought this machine, it was a jackpot, Williams jackpot machine from 1972. This was the top plate. So here was the score display. It was already taken off when I took this photo. Here the scores were displayed and the player number or something. No, we never found out what this is. You can see, you can guess the style of the machine. The playfield looked like this. Okay, here we also already started disassembling it. What we did was, in order to get it alive again, we first had to kill it, basically. So we took everything, nearly everything apart. We took off this playfield. You can see it here. So this is the playfield with all the stuff up here, all the obstacles and everything removed, so that it is a plain surface. This is the obstacles we removed. And what is it called? Schmiergeln? Anyone? No chance? We removed the lacquer by first heating it with a heat gun, also on the outside of the box, heating it with a heat gun, and then we had to rub the rest of it off. And then we had to recoat it, of course, with several coats of special new lacquer and some wax as top, some hardening wax as the top playfield layer, so that it gets more smooth and shiny. And what we ended up was this playing field after this one. So all the kitsch is gone, but of course all the colors are gone with it. We even cleaned those bumpers to remove everything that reminded of getting a score, because we wanted the scores to be gone. We also removed this jackpot wheel thing here and made it kind of non-jackpot reminding. Yeah, what else? This stuff that's bonuses. It looks far simpler and far more, how should I say, basic now, of course. Some photos of this renovation task. This was, of course, hugely unhealthy. We had to wear these masks because the lacquer was from the lowest layer was from the 70s, and then there was one layer from the 80s, like glittering lacquer. And then there was letters stuck on it, like stickers. They were from the 90s, I guess. And this was 2 months of headache, basically. Fares, of course, also did something. Yeah, in the beginning we tried to use mechanical stuff to get it off, but that didn't work. We had to do it by hand because those machines are somehow a bit, yeah, okay, we bought the cheap one. Anyway, of course we also had to rework the electricity, because electromechanical, not electronic mechanical. This is what a machine like this looks inside. You can look into it later. Anyway, this is more or less, all of this is solenoids, so coils that push something, either a button to close it, or they push the ball up. If the ball falls into a trap, then it's pushed up by some coil. The whole machine runs on 27 volt. It should be 24, but it's 27. I don't know why. It reads 24 here. And another circuit of 6 volt, which runs the lights. This stuff we found out. And what we did in here is we connected a lot of stuff to the machine. More details later. So here you can see our new cables in this cable salad. This is the wiring diagram of the original pinball machine. We were never really able to read it. We always tried it. It's the biggest PDF file I own. We really tried to read it, but it's not only tiny letters, it's also very strange letters. We sometimes find familiar words on it, but basically it's easier to guess or try out stuff than to read this diagram, at least for us. We are both no electronic engineers. What we also tried was, in order to give you the feeling of playing the sound, you of course had to we had to somehow measure what is happening on the playing field with sensors. But instead of placing sensor elements on the playing field, we tried to tap into this pinball network. This is why we tried to read this diagram, also to repair stuff, of course. And after several experiments that didn't work out and several ideas of how we could do it, we somehow found this diagram of an optically, galvanically, I don't know if this word exists, of an isolated, what is it, sensor for measurement unit, or what you would call it. So you connect something between 5 and 24 volt here, and here you get 1 or 0 TTL 5 volt stuff that you can hook up to a microcontroller. We soldered this several times. It's from 5 to 24 volt. But the problem is that what we didn't try out, because we had no oscilloscope, was if 27 volts are too much for this circuit or not. And obviously they are too much. We had a burnt resistor yesterday in the evening when we first let it run for more than a couple of minutes. Somehow this guy gave up. So if anyone in this room can explain me how to get this number to change to 27 or even 30 would be nice, then I would be very happy, because I don't know how to calculate this stuff. We have diodes here and this horrible thing with 3 connectors. No. No, we really have a problem because we wanted to measure several things like if the ball crashes into a bumper. We get this through a microphone now. We placed 6 microphones in this table. But if it hits here, we would of course love to get a detailed measurement, like in this point it hit. This is what we wanted, and this is what we got for few seconds. Also, if the ball drops out of play, we would be able to measure it, but we aren't. We are nearly. We can measure it for 5 minutes, then the circuit burns through. As a microcontroller, of course, we use the Arduino because it's so politically correct to use open source hardware. I heard the story that it was stolen from the original creator, by the way, who didn't want to release it, and someone else placed it onto a liberal license then. So it might be not this politically correct after all. But anyway, great microcontroller, very easy to program. What we do is anyway very simple because we only use the digital inputs, and we plug it in and look if it's 1 or 0 that comes in. So very straightforward. This is not the hard part. And since it's really, we have an optocoupler on this last thing. What you have in the middle here is an optocoupler. It's like a small light signal station where one here is diode LED guy who stands with a flashlight and morses information here. So it's electrically completely separated. There is just information crossing this border. So if this burns, it can't hurt the Arduino, it can't hurt the computer. Very clever circuit, basically, but a bit too weak for us, obviously. For the software side, we use Pure Data, which some of you might know. It's an open source audio software. A project started by the same guy who did Max MSP. Actually, he started afterwards because he somehow wanted to have Max MSP to get open source, but it was owned by a company, so he had to do his own open source software. It's a very robust and good audio software. Just the interface is a bit clunky, TK, old school thing. You can see that it doesn't really fit into the polished surface of the Macintosh. But anyway, what this allows us is to sample several channels of sound at the same time, because we have 6 microphones built into this machine, most of them piezo microphones that are just glued to the playing field. We need to be able to record them all 6 streams at the same time. And this is very convenient in PD, actually. We just record into buffers and we play these buffers smaller, slower, yeah. However you play. So in the moment this piece is 80% finished, I would say. There are some things that are, as I explained now, not yet working. Like this measurement would give us more depth somehow, because it would feel more, you would feel more responsible for what's happening. Maybe this is the right way to put it. Somehow closer to what's happening if there is more synchronicity. Then another thing is we still need to decorate it a bit, because I mean I like the green, but it's somehow a bit boring looking, I think. And the third thing is we still have a speaker problem. I would love to put horn speakers here, so we will build horn speakers that we just place here, like, no, maybe not this size, like this, 2 horn speakers. The horn speakers don't have a bass, so we might need an external subwoofer or something to get more bass out of it. But this is stuff that we will do over the summer. Otherwise, the hard part of renovating this piece and getting it smoothly running again, exchanging all the rubbers and all this bending everything so that it really works neatly, is done. Yeah, here's our inspiration for the horn. This was a piece I saw in Riga at the Art and Communication Festival at the last. It's a giant horn, not horn speaker, but only horn. You can blow into it here. It looks like it goes out of the window, but it doesn't. It stops here. You can go there and go. Very nice. Something like this will place here, approximately, a bit smaller maybe. So what I will do now is I will show you. I will show you now how you can play it later. we have two more people, Fares and Peter, talking, and after their talk, you can try out all our stuff. Fares' instruments and Peter's instruments, and this stuff also. But now, before that, I will quickly. I hope I get some audio. And Fares, I think you said you put the camera here. So if you play later, it's best to get the ball into one of these pockets up here. Because up here, then the sound changes. This is kind of the goal for playing it. If I don't manage to put it up here, it will sound very tame and only sometimes you hear something, but of course I'm not playing very good. I don't manage to get it into the corners. Go to the next one and you try it later. Yeah. It's a challenge. It's very hard. The flipper machine was one of them has not good.
Okay.
Okay. Hi. My name is Fares Kayali, and I will talk to you a little about homebrew music games with a special focus on this little gadget, the Nintendo DS. So, when you look at homebrew development, one of the big reasons for it was emulation, to bring old games, older gaming systems to new devices like the DS, where you can play a whole lot of games from years past. What you see here is the Scum VM emulator. It's an emulator for old LucasArts adventures, like Day of the Tentacle. The other reason for homebrew software, of course, is to develop original games. So, to get ready for homebrew development, first thing you need to do is to hack your device, unfortunately, which brings some problems. In the beginning, to develop for Nintendo DS, you had to flash your firmware, which is no big thing, but it voids your warranty. So, I have some problems to face. Now you just need some special game cartridges, so you don't have to modify your hardware, which is of course better. I will spare you the rest. This is what Peter will talk about. Peter will give you insights on the technical side of development for the Nintendo DS. These problems and yeah, you also have the need to hack your device to play those homebrew games as well, not only to develop, of course. All this doesn't stop the homebrew scene from being a very active one, of course. And we were active as well, developing our own games, we will show you later. So, when you hacked your gaming device, you want it to become a musical instrument. So, when you're building musical instruments out of something else, it's a process of appropriating a thing which originally might be meant for another purpose, like this. This is the Gemüseorchester, the vegetable orchestra. They build instruments out of a cucumber or an aubergine. Stuff originally meant for eating, not for playing music. We'll take it a little easier. We will use systems that are originally meant to play, so it's a little bit nearer. So we'll take a look now at how to use a video game system to build a musical instrument. So that's what happens when I take this literally, when you this is a Nintendo Entertainment System made into a guitar. So that's also not quite that what I'm talking about. We were interested in was the software side. So there's some people who are already very successful using gaming devices to perform live. These are two pictures of the Game Boy Music Club who use a homebrew software named Nanoloop, which is a tracker used for sequencing loops. And they play live, and they play live together with several Game Boys at the same time. So this is one possible use of a gaming system as a musical instrument. We have similar software for the Nintendo DS. This is Nitro Tracker. So it's a full-fledged sequencer. You can put your samples here. You can use MIDI as well over the Wi-Fi capabilities that the DS had. So you can expand your possibilities on stage when you use this software. You can even do sampling because the DS got an internal microphone. So you can use this to record samples and use those samples with this software. So another great way to play live with a gaming system. The other thing homebrew musical instruments might be, they might be more of a computer game. There's a reason I put those two here, because they have many things in common. The first thing when you think about building games that are musical instruments as well is you're bound to having to wage between some kind of freedom of expression you give to the player, and on the other hand, providing a somewhat guided experience. So having a kind of safety net that ensures you have well-sounding results. So you always have to balance between those two factors. These two examples are both homebrew software, of course. One is Amplitudes, the other is Frets on Fire for the PC. Amplitudes is for the DS, as the name implies. What they have in common is they share a very guided experience in playing. You have to rhythmically pick up items, you can see it very well here, to activate a musical score, to activate a track to be played. So you have no real freedom of expression here. If you press the wrong button, you will have something that does sound clanky or something like that. On the other hand, you have a very satisfying experience, as if you play it right. You have real songs, real well-sounding songs. Those two have another thing in common. They are both rip-offs of commercial games, which is also interesting in the context of homebrew software, because many homebrew games just recreate commercially available games that are not available for that special system. So this is an implementation of Guitar Hero for the PC, which you can play with your keyboard, or you might take your keyboard like this. And you also can use the original Guitar Hero controller. Amplitude is a clone of Amplitude, which was a PS2 game from Harmonix, the company that also did Guitar Hero eventually, where you have to rhythmically press buttons on the joypad to activate the score. Amplitude is quite funny because it has really cool songs. You can play the Mario theme or the Turrican theme if you know it. It's an old Amiga game. They have a third thing in common, which is quite interesting, and what might be the reason they were rip-offs of original games is they both rely on user-generated content. So everybody can make a song for Amplitude or for Frets on Fire, and therefore you have a vast amount of songs that you can play, which you don't have on the original games, or you have to pay extra for every 3 songs of Guitar Hero, which No, not all of them are good. So this is an example of a somewhat more guided experience. Is the sound on the left channel?
Yeah.
Okay. Of course, there are other gaming environments that give you more freedom of play. This is the quilted sword organ. It's created with the Quake 2 engine, and it's an audio environment where you can walk around and activate sounds. Of course, it sounds more chaotic because there's not so many rules that ensure the outcome. Oops, I think that's my fault. I'm sorry. Nicht? Okay, sorry. Kann ich es jetzt rein, leise? I think you hear a little, okay. Good. Okay. So, obviously you have more freedom here. The other example, which is also it. Kann ich das nicht anstecken? Schlecht, okay. Good. Then let's just talk about the name. It's called gioioso. It's an Italian term meaning to joyfully play a certain passage of a composition. And I think that's what it's about when you create music games. You have to provide a playful experience for the player, which on the one hand gives him some freedom to play with, and on the other hand ensures that after 5 minutes you really get good sounding results, which you don't have if you play a real instrument, of course. So to get what Peter and I did, we made some experiments with music games on the Nintendo DS. So we tried to develop playful interfaces that more or less act as examples how you to extract certain qualities that are interesting if you design music games. And the other thing is we tried to make use of the stylus you have to control the DS with a touch screen, and find some gestures how you could use this stylus to produce music. So what I will show you now, and then I definitely need to put the check in.
No, this you have to check in.
Yep.
Sorry.
So
cut it
just
from the live
just
signal
do it.
maybe, but
So I think Peter will help me, or you, should I? Oops. Kann man das schon aktivieren? Das kann man schon aktivieren. Oops. So this is homebrew software now. So you see perhaps you can think that this is the interface of the EZ Flash 4 cartridge. So this one relies on a flashed firmware and then puts a cartridge in the Game Boy Advance slot, which uses some kind of exploit to run DS games as well. Oops. So this is called a Thumbtack, Reisnagel auf Deutsch, because they happen to look like that, and you might control it with your thumb. The gestures that are interesting here is especially catching and throwing, so you can throw the thing. I will just show you. I hope we have sound. Let's quite. No. Turn it up. Yes. Just see what happens. It's a little blurry, I think.
I think I can change.
I think you can see it yourself.
Apfel L. Jetzt lassen wir mal Play und Fullscreen.
Also der Luft nicht, deswegen. So, thank you for and let's go to Peter. Yep. Gut. So. Okay, good.
Yeah. So, good evening. My name is Peter Kotik, and after the presentation from Faris with this graphically intensive, I'm going to present some short textual facts on the technical background. The reasons for hacking the DS is what can you do with homebrew software? We have three big points. Emulation, so people build emulators for various console systems, so you can play the old games from the Nintendo Entertainment System, from the Sega Master System. Faris showed a screenshot of the SCUM VM, which is used to play the old LucasArts adventures like Day of the Tentacle and Monkey Island. Then of course homebrew games. Some are clones from commercial games, and there's a lot of stuff going on in the application sector, like text viewers and web browsers, which are originally not available for the Nintendo DS. The one negative side that the homebrew community is always facing is piracy, because the knowledge gained from the homebrew community, like hacking and decrypting DS, can be used to run pirated copies of commercial games. But as far as homebrew software is concerned, and unauthorized selling and copying is done, then homebrew software is legal. Well, at the end of my presentation, I'm going to show you my hack of the DS, which I created a real-time musical instrument. But before that, I'm going to explain how we did it, what kinds of development tools and libraries we used, and it could also serve as kind of a starting point if you want to try some homebrew development of your own. So basically, what do you need to set up a working development environment? As a compiler toolchain, we used DevKit Pro. It is available for various consoles and handheld consoles, and in various processor flavors. The interesting part for our side was the DevKit ARM tool, because the Nintendo DS has two ARM processors. It has an ARM9, which is the main processor responsible for running the code and getting the input, also interfacing with the 3D graphics subsystem, and an ARM7 subprocessor, which is responsible for interfacing with the sound hardware and also reading the touchscreen. The library, well, there are two libraries that are used here. One that is a very low level. This is the libNDS, and a higher level library which is built on top of the libNDS, the PA-lib. The libNDS is relatively low level, so you're dealing with hex addresses and interface write directly the various registers that the DS has, whereas the PA-lib is a much more user-friendly, beginner user-friendly environment, and a lot of procedures are already available that shield you from the actual hardware and processors of the DS itself. Visual Studio we used as an integrated development environment. It can be, there's a lot of documentation, by the way, available. I'll give you some links to resources at the end. So how to set it up, and it's really a matter of half an hour. Basically, in the Visual Studio environment, you set it up one click. You compile your written code, which is C or C++, and then you can set to run and test the code you wrote. You can use either an emulator, which kind of is software Nintendo DS. What we needed because we needed a lot of sound and an exact emulation of the sound, and there are about 4 to 5 emulators available, but they didn't have a very good sound reproduction or no sound reproduction at all. But there is one, and this has been in recent development. The latest version is about 2 or 3 months old, from No Cache GBA, which was originally a Game Boy Advanced emulator, but is a Nintendo DS emulator now as well. And the latest version offers some very good sound compatibility, and actually can run our sound tools that we programmed. The 100% compatible way of testing your code is, of course, putting it on the DS and to run it. Well, how does this work? For some who are not that familiar with the DS, it has here on the upper side slot 1 cartridge. This is where the original Nintendo DS games go, and here on the other side is a Nintendo Game Boy Advance compatibility slot. So games and code run here from the slot 1 is encrypted. So you can just, and the encryption hasn't been cracked in the beginning, so you couldn't run your code from here. What was Faris using when he showed his program? He had actually a card in his Game Boy Advance slot, and used a so-called passkey, which was in slot 1, to trick the DS into executing the code. So this passkey just basically tells the DS when you turn it on, your code that you have to run is, and then you just point at the Game Boy Advance slot. Newest development now have made it possible to have everything you need in one small slot 1 card. So a passkey and a card that you can put your code on into it. There are basically two variations. One version of this card uses a micro SD card, which you put into the actual slot 1 card. So if you write code, you have to take your slot 1 card out of it, put the micro SD card out, then you put the code on and then put it back on. So quite a time-consuming procedure. A better version, what I'm using, is a slot 1 card called DX Extreme, which has a mini USB connector. So you can just hot plug it play via USB, which is a lot quicker. Okay, now into some hardware details, mainly concerning the sound. The DS has 16 hardware sound channels, which are numbered from 0 to 15, that are controlled by the ARM7 subprocessor. When you write code in the low-level library, in the libnds, you have to write code for both processors, because those processors have to communicate with each other, and the ARM9 has to tell the ARM7 to do some sound code and then communicate back and forth. So it's quite a challenge and rather complicated. And what we have done now is that it's possible in the PA-lib to just write one source file, and you don't care on which processor it is run, because the PA-lib manages that for you. The application, Fares was looking for some kind of real-time audio for some of his graphical applications, and he wanted to be fast and real-time. And DS features what is called a PSG, a programmable sound generator, that it inherited from the Game Boy and the Game Boy Advance, which is mainly a hardware synthesizer that can produce some old-school sounding noise and sounds. And from these 16 channels, for channels 8 to 13 can play these PSG sounds, and channels 14 to 15 are used to interface with the noise generator. And in my application, I've used both of them to create this some kind of fun instrument. Yeah, the technical reference, those are two links where you can find plenty of info. The latter one is a good collection of links, so basically those are the two ones that you need. And the first one is a good technical reference and description of the DS hardware internals. So you have all the registers there and all bit descriptions and so on. Okay, now on to the application. Well, what I did was use the touchpad of the DS to map commands for this programmable sound generator. So we have, if you see, the touch screen is available on only the lower screen, and the upper screen is used to display some technical info. So I've mapped here from left to right, from deep sounds to high-end sounds. It goes about 300 hertz bass sounds to 20 kilohertz high sounds. And then on the y-axis, we have, you can modify this PSG. Yeah, it's called duty cycler, but it manipulates. Okay, maybe I show it. Okay. Should be much lower. Well, this is and then and well, we can use and I've made some based on axis sound. I've made some kind of